Hello, so in this video we're going to look at polar coordinates and complex numbers. And so first I want to look at some notes, which you're more than welcome to write down in case you want them or think might be helpful. And so some notes that I've also written down, you can go from x and y over to radius and theta. So you can go back and forth on these two. And then I've included the x and y coordinate where you can show how the triangle looks and where it lies and where the points or where to put the x and y's or the radius and theta. I also include the x is equal to r cosine theta, y is equal to r sine theta, and then we have this r squared equals x squared plus y squared, which if you were trying to solve an equation, you could use that to figure out a form to get the answer. And then you also could, if you're just looking for the radius, you could square root the x and the y squared and then solve for r. I've also included this z equals r cis sign, and it's interchangeable. So sometimes you will see it written as this, and then sometimes you'll see it written as this. And so you can write them back and forth. And then the standard form of a complex number is a plus bi, or with the x and y's, you can write it as x plus yi. I've also included the unit circle, and so there's going to be times where you might have, let's say, sine, and so you want sine of 7 pi over 6, and so you can see that sine pi over 7 pi over 6 going to 7 pi over 6, and sine is y, you will see that it's negative 1/2. And then I include that tangent is equal to y over x, and x cannot equal 0. When you're doing theta, you'll do tangent negative 1 y over x, and there's some of these problems where you have to be in a certain radius, so you'll have to be in 0 degrees to 360 or degrees, or 0 and 2 pi. So sometimes you might have to go back in between and subtract to get to the range that you are looking for. And then you have sine is equal to y over 1, which is just y. Cosine theta equals x over 1, which equals x. And then tangent, which equals y over x, and x cannot equal 0. So let's look at some examples to go over some of these concepts or these formulas that could kind of help. So first we're going to look at 7 pi over 6. And so for this one, we have it in radius and theta, and we want it to go to x and y. So I would draw your picture first. And so we know that 7 pi over 6 is down here in the third quadrant. We have our theta. We know that our radius is 7. Our x we do not know yet, and we don't know our y yet. And if you remember from the previous slides, or you've already known before, x is equal to r cosine theta, and y is equal to r sine theta. So let's do the x first. So if we know that the radius is 7, and we know that cosine of theta, and we know that theta is 7 pi over 6, negative square root 3 over 2, and that will equal for x 7 square root 3 over 2, negative. That would be our x value. For our y, we know that our radius is 7, Sine, we know that our theta is 7 pi over 6. Looking at the unit circle, you will see that y is equal to negative 1/2. And then you have 7. And this one will equal negative 7/2. And you can write it in the form of a coordinate point, or x and y. So you would write it as -7 square root 3 over 2, comma, -7 over 2. And that would be your answer. For the next one, we have -3 pi over 6. And so for this one, we're going from radius and theta, like we did in the last one, over to x and y's. And so if we draw a picture, we know that pi over 6 lays over here in the first quadrant. We have our theta, we have our right angle, and then we have y, and then we have our x, and then we know that our radius is 3. And your radius or your hypotenuse is never negative. So I would remember that. So we know that x is equal to radius cosine theta, and y is equal to r sine theta. For x, we know that r is equal to -3. And then we have cosine of pi over 6. And looking at a unit circle, cosine pi over 6 is just square root 3 over 2. In writing this out, we would have x is equal to -3 square root 3 over 2. And that would be our x value. For our y, we know that the radius is -3. Sine, we know that our theta is pi over 6. Looking at the unit circle, you will see that pi over 6 is 1/2. In writing the y, you will get -3/2. And you can choose to write that in the x and y coordinate plane if you would like. For our next one, we have 4, 2. And so in this case, we have it in x and y terms. And we want to get it to radius and theta. And so drawing out our picture, we can go 1, 2, 3, 4, 1, 2, and it would be kind of over here. And so you can draw that, and you can kind of see this imaginary triangle. And so for r, remember how we were just looking for the r value, we could write it as square root x squared plus y squared all over a square root, all under a square root, excuse me. We know that our x is equal to 4. And our y is equal to 2. 4 squared is 16, plus 2 squared is 4. And you'd get square root of 20. But then you can reduce this square root, because it can also be written as 4 times 5 in a square root. And we can get this 4 out to a 2. So you could write it as 2 square root 5, which equals the r. For the angle, we have tangent of theta equaling y over x. Tangent of theta equaling 2 over 4. Going theta equals tangent. Plugging that into your calculator, you would get 26.5050518. And then theta would equal approximately 26.57 degrees. So for this one, we have x squared plus y squared equaling 3x. And if you remember that x is equal to r cosine theta, and y is equal to r sine theta. And so for these, such as this one, we're going to get to the point where r equals a value. But you don't want the x's and y's inside it at all. And so for this one, we have our x squared plus y squared equaling 3x. I'm going to take this r cosine and r sine and plug it in for my x's and y's. So we would get r cosine theta squared plus r sine theta squared equaling 3 parentheses r cosine theta. Distributing out the squared, we would get r squared cosine squared plus r squared sine squared equaling 3r sine, or cosine, excuse me. So then I would factor out on this left side the r squared, and you would leave behind a cosine squared plus a sine squared equaling 3r cosine. And so if you know your trig identities, or if this looks familiar, in either case, we can write this cosine squared and sine squared when they're added to each other is equal to 1. So we can write as r squared 1 equaling 3r cosine. And then dividing out on this right side an r from both sides, we would get left with r is equal to 3 cosine theta. For the next one, we are looking at x squared plus y squared equaling 64. And so for this one, if you like we used in the last one, we have x is equal to cosine or r cosine theta, and y is equal to r sine theta. So if we write this in terms of r cosine and r sine, we can write it as r cosine theta squared plus r sine theta squared equaling 64. Then when we distribute out the squared, we get r squared equals cosine squared theta plus r squared sine squared theta equaling 64. We can do similar to what we did in the last one. On the left side, factor out the r squared, which leaves behind this cosine squared theta plus sine squared theta equaling 64. And so if you, like I said before, if you know the trig identities or they look familiar, in either case, this is equal to 1. And so we are left behind with r squared 1 equaling 64, or r squared equaling 64. And then square rooting the 64, you get left with r equals 8. For the next one, we have x squared equals x squared plus. For the next one, we have x squared plus y squared equaling 9. And so the last one, we could have done the same thing, where since we haven't the terms of x plus y squared, we can just follow the pattern of x y squared equaling r squared. And so rather than going through this hassle, we can just look at the right side of the equal sign and write them together. R squared equaling 9, square root, r equaling 3. And so we could have done that in the last one, but I wanted to kind of show you through the work and kind of see what it looks like. So for the next one, we have r equals 3 sine theta. And so for this one, we can use a variety of different methods. And so we have, or techniques. And so we have x is equal to r cosine theta, y is equal to r sine theta, and r is equal to the square root of x squared plus y squared. and then r squared plus or equal to x squared plus y squared. So for this one, we can multiply r on both sides. Multiply r on both sides. And you would get r squared equaling 3. On the right side, you would get 3r sine theta. And then, if you remember, this r right here, r sine theta is equal to y. So r squared equaling 3y. And then when we go to put it in our equation, we can also look at this. X plus y squared equaling 3y. And then putting it back, we can move this x or y, negative 3y over, and we would get x squared plus y squared minus 3y equaling 0. And this one, we're just trying to figure out what shape a certain circle is. So if it's a circle, if it kind of does a shape. So in this case, we have it equaling a circle. So for this one, we have 8 minus 4i. And so we can look at and remember that it's given in the terms of the standard form being a plus bi, or you can look at it as x plus yi. And so if we look at it in the terms of x and y, we know that this is our x and that is our y, and our x is equal to 8, and our y is equal to negative 4. And so for this one, we wanted to get to the terms where z is equal to rcis theta, or you can write it out longer to z equal r cosine theta plus I sine theta, and like that. And so for this one, we want to get it to the point where we have this r and sine value, or r and theta value. So if we would do the x's and the r first, you know that r is equal to the square root of x squared plus y squared. We know that our x is equal to 8. So you go 8 squared, and our y is equal to negative 4. And you can write that in squared. We know that 8 squared is 64 plus 4 squared is 16. And that would equal square root of 80. And you could also simplify this radical. So we can go to 16 times 5. And pulling out the 16, you'd get r is equal to 4 square root 5. And then looking at the theta, we know that tangent of theta is equal to y over x. So for this one, we know that we get that theta is equal to tangent negative 1 over y over x, which is negative 4 over 8. Plugging that in your calculator, you'll get negative 26.565. And so this is one of the cases where you will add 360 degrees to it to get it in the range of 0 and 360 degrees. So if we go 360 degrees minus the 26.565, we would get theta is equal to 334.34 degrees. And then all we have to do is write it in the terms of z equals. So writing it out, we would get z equals the short version, which would be 4 square root 5 CIS 334 34.34 degrees. Or you can write it out the long way, z equals square root, or 4 square root 5, parentheses, cosine 334 plus I sine and that either way would be correct, in my opinion. For the next one, we have square root of 3 plus I. And so we know that our x is equal to the square root of 3, and our y is just 1. We get that r is equal to square root of x squared plus y squared. Plugging in our x, we get square root of 3 squared plus y, which is 1 squared. 3 squared is 3 plus 1, and r would equal square root of 4, which is equal to 2. Then we go for our angle. So we know that tangent of theta is equal to y over x, and x cannot equal 0. We get tangent of theta is equal to 1 over square root 3. Theta would equal tangent negative 1 over 1, or the inverse of tangent being square root 3. And this would just equal pi over 6, or 30 degrees. But I'm going to leave it in terms of radians. So you have two ways writing it out, or the short way. We get z equals 2 cis pi over 6, or z equals 2 parentheses cosine pi over 6 plus I sine pi over 6. And either way would be your correct answer in terms of z equals. So for the next one, we have z equals 7 cis pi over 6. And so for this one, we're just trying to figure out what the values of x and y, or a and b, are. So if we write this out, we would have z equals 7 cosine theta, or pi over 6, plus I sine pi over 6. And so since we're looking for in the terms of x and y, or a and b, we know that if we look, we know that our radius is this r up front. Our x is our cosine. So if we look right here, we have our cosine theta, which is our theta is pi over 6. And so we have our x, and our y is the sine theta, which is just, in this case, is sine of pi over 6. And so if we look at it, we can write this, I'm going to write it in terms of a. So a equals r cosine theta. And for r, we know that it's 7, and then we have our cosine pi over 6. Looking at the unit circle, you will see that cosine of pi over 6 is 3 square root 2. Or square root 3 over 2, excuse me. And we can rewrite a is equal to 7 square root 3 over 2. Our b, we can look at and write it as r sine theta. And then we can look at it and know that our r is 7, and our sine is sine of pi over 6. Looking at a circle, you'll see that 7 or sine pi over 6 is equal to 1/2. And b would equal 7/2. In writing it out, you could leave it, for me, I would leave it like this, or you could write it out in the terms of the a and b, which is the standard form, or the x and y, which I would recommend as well. So you could write it out as 7 square root 3 over 2 plus 7 over 2i. And that would be your answer as well. So for the last one, we have z equals 3 cis 240 degrees. And so for this one, we're going to do what we simulated, same thing what we did in the last one. And so we can write out this as z equals 3 cosine 240 degrees plus I sine 240 degrees. And we know that z equals the a plus bi, or we could write it as z equals x plus yi. So we know that out front is our r, so we have our r. We know that in the cosine theta is our x. This sine theta is our y. I'm going to write in terms of a again and b. So a is equal to r cosine theta. We know that our r is equal to 3, and our cosine theta is 240 degrees, so cosine 240 degrees. Looking at the unit circle, you'll see that it is cosine of 240 degrees is negative 1/2. And a is equal to negative 3 over 2, or 3/2. For b, we know that it's r sine theta. We know that our r is 3, and our sine is sine of 240 degrees. Looking at the unit circle, you'll see that sine of 240 degrees is negative square root 3 over 2. And we can write b is equal to negative 3 square root 3 over 2. And writing in the terms of the a plus bi, or the x minus yi, we get negative 3 over 2 plus, or minus, since we have a minus out front, over here with this negative square root 3 over 2. So minus 3 square root 3 over 2. And that would be your answer.